Hello, algebra students. Mr. Lawrence here with your flipped lesson. Hopefully you did your best on your test today, and hopefully I'll have the results for you tomorrow. But today we're going to start working on some word problems. We're doing a little mini unit here on story problems, making sure you're good with them, because Chapter 7 is going to require you to be pretty darn good with them. And you're going to start to see why we're learning some of these algebraic techniques. Appreciate your patience. All right, so let's get down to it. Let's see, first of all, the sum of three consecutive even integers is 48. What are the integers? Now, I know some of you are just going to want to figure it out. However, to get full credit, and I hope you're listening to this, Sage, to get full credit, you're going to have to be able to provide an algebraic solution. You're going to have to be able to set up an algebraic equation and then solve it. And if you just give me an answer, you're only going to get credit for the answer. You're not going to get credit for the work part of it. So the first thing I want to do is I want to define a variable, or I might have more than one variable. I need three consecutive even integers. Well, do I know the first of these integers? No, I don't. So I'm going to let x be the first of the even, even integers. Okay? Now it does not make x automatically 2. All right, because 2 is not the first even integer. 0 is an even integer. -2 is an even integer. But it's going to be the first one in the context of this problem. All right, well, what would be the next even integer? If the first one's x, the next one would have to be 2 more than x, wouldn't it? X plus 2 is the second even integer. Okay, and I'm lazy, so I'm not writing all those words, but that's what it means. And then if the second one is x plus 2, the third one must be x plus 4. Some of you just got confused. You don't know where this came from. Well, think about this. Pretend the first integer was 2. What would be the next even integer? It would be 4, right? How do you get there? 2 plus 2. And then the next one would be 6. And that would be 4 plus 2 more. Or you could say 2 plus 2 to get to 4, then plus another 2 to get to the 6. And that's the same as 2 plus 4. If my first even integer turns out to be 10, okay, well, to get to the next one, I will add 2. To get to the next one, I would add 2 more. So how much have I added from 10? Well, from to get 10 to 14, I have to add 4, don't I? So you see, if the first one is x, I add 2 to it to get the second even integer, and I add 4 to it to get the third even integer. Okay, now if I only wanted consecutive integers, I wouldn't be adding 2, would I? See if you can tell me on Class Friday what you should be adding. All right, so I know the sum, and I see the word sum right here, of the three consecutive even integers. So that means x plus 2 plus x plus 4. Now some of you are going to be tempted to put parentheses in here, and I'm going to say don't do it because they absolutely don't do anything for the problem. They're unnecessary. Do not put unnecessary symbols into your problem. All right. Is, that means equals 48. On the left-hand side, I combine my like terms. It looks like I have 1, 2, 3 x's. 2 and 4. Well, that makes 6. And it still equals 48. Now I have a simple two-step equation that I can go ahead and solve. I'll get 3x is going to equal 42, dividing both sides by 3, and I believe I'm going to get 14. So so x equals 14, x plus 2 is 16, and x plus 4 would therefore be 18. And there are your answers. There are the three integers. Now again, I know that some of you are going to go, I can do this in my head. Some of it you can and some of it you can't, but you're going to be graded on whether you can write an algebraic expression and solve it. Doing it in your head doesn't satisfy that requirement. Okay, let's take one look at a different one. 17 decreased by twice a number. Well, I'm going to let n be a number, right? N is going to be my number. What do I have to do to n? Well, I'm going to need twice n. Well, so I'm going to need 2n, right? Twice n. Now I need to take 17, decrease it by twice n. So I'm going to have 17 minus 2n is 5. And there's my equation. So to solve this one, I'm going to subtract 17 from both sides. By the way, I expect you to be an expert at that. If you're not, you better come on in and help. I've already been teaching my pre-algebra kids how to do this. You should know that you should subtract 17 here. If you don't, come on in for help, please. All right, I get negative 2n, those cancel, and I get 5 minus 17, which would be negative 12. Dividing by negative 2, n will equal a positive 6. So the number is 6. So let me check it. Uh-oh, something's not right. 17 decreased by twice the number. Oh yeah, I'm going to be okay. Well, I need 17 minus 2 times 6. So I get 17 minus 12, which is 5, and that's what it's supposed to be. I did it correctly. All right. This time I need 5 less than a number tripled. So let n be the number. So then 3n is the number tripled, right? Now I need 5 less than that. Some of you are going to write 5 minus, and that's just not the case. Let's play a little game. I give you a number, you give me 5 less than it. 6. Of course, the answer is 1. How'd you get there? I subtracted 5. That's how I took 5 less than the number. Let's try again. 17. Okay. Of course, you're saying 12. How'd I get there? I subtracted 5. Okay, let's do a hard one. Let's do 118. Okay, I'll bet most of you can tell me it's 113. How'd you get there? I took away 5. 5 less means minus 5, not 5 minus. Okay, so 5 less than a number tripled. So 3n is my number tripled. I need 5 less than that, and that's going to equal 16. When I solve this, I'm going to get 3n is going to equal 21, and then n is going to equal 7. So the number is 7. Okay, let's go down here. Karen has 6 more than twice as many newspaper customers than when she first got her route. She now has 98 customers. How many customers did she have when she started her route? Well, let's see here. 6 more. 6 more. If 5 less meant minus 5, 6 more must mean plus 6. Twice as many. 6 more than twice as many. How many newspaper customers did she start with? I don't know. So we're going to say let n be the starting number of customers, right? I need twice as many. Okay, so that'll be 2n. I need 6 more than that, plus 6. And she currently has 98 customers. So I'm going to subtract 6 from both sides. 2n is going to equal, oh, silly Mr. Lawrence, it's 98, not 90. Not 9. It's going to be 92, right? Okay. And dividing by 2, I should get 46. So Karen started with 46 customers. And there you go. You can check it. You could double 46 and then add 6 to it. And sure enough, you'll get 98 when you do it. But there's your answer. All right, so the next several days, we are going to be working on different types of story problems. All right, and remember the emphasis on algebraic solutions. Okay, Mr. Lawrence signing off. Good night, everybody.